Here is an idea that sounds a little circular, and honestly, that is exactly the point. Recursion. A recursive function solves a problem by solving a smaller version of the very same problem. And the whole art of it is knowing when to stop. Every recursion needs exactly two ingredients. First, a base case, an input so small that you can answer it instantly with no further calls. Second, a recursive case. You shrink the problem a little and you call yourself. Let's make it real with factorial. 5 factorial is just 5 times 4 factorial, and 4 factorial is 4 times 3 factorial. And down we go, until at last we reach 1 factorial, which is simply 1. No more questions to ask. That is our base case, the floor that finally catches us. Now here is the part most people never get to see. What is actually happening deep inside your computer's memory? Every time a function calls itself, the computer stacks a new frame. A little box, holding that call's arguments, its local variables, and a note saying where to return when it is finished. So the calls pile up: 5, 4, 3, 2, 1. 5 frames deep, and not a single one has returned yet. They are all just waiting politely, stacked on top of one another. Then we touch the base case, and the magic runs in reverse. The frames unwind. 1 returns 1, 2 returns 2, 6, 24. The answer bubbles back up the stack, frame by frame, until there it is, 120. But do be careful. Forget the base case, and the stack just grows, and grows and grows, with nothing to ever stop it, until your program runs clean out of memory and crashes. That is the famous stack overflow. So when should you reach for recursion? Whenever the problem is itself recursive, a tree, a graph, anything that splits into smaller copies of itself. Hold on to that thought, because we will use it everywhere.